Well, welcome everyone. It is 5:30, so we will go ahead and get started. My name is Sierra King, and I am the admissions manager at the Data Incubator, and we are a fellowship, scholarship, and placement company. We promised you an excellent info session today that will be led by one of our instructors, Michael Cullan, and I will link a notebook in the chat that Michael will be using during his presentation, so please make sure you have access to this and can follow along. If you need it resent, please let us know. We're happy to do so. To start things off, I would like to give you a quick overview of our program and everything that we offer, and then Michael will jump in for our live demonstration, and we will leave some time for questions at the end. Please place all of your questions in the Q&A section, and we will answer them at the end of the presentation. As a reminder, our session is an hour long today, so if we don't get to all of your questions, please email us at admissions@thedataincubator.com, and we will be happy to help you. So kicking things off, the Data Incubator focuses on training people to become data scientists. And why is that important? It's really because data scientists have the ability to work with the latest tools on unstructured and structured data to drive business value. That's a big need in the world right now. We work with companies in a ton of different industries, ranging from tech to finance, retail, healthcare, and many more. Every company has data and they want to use that data to drive value for them. There are a lot of other data focused programs out there, so I'm sure you're wondering, what do we do at the Data Incubator that's a bit different? Well, what we've found is when you look at training, there are really two types. One is fast-paced and efficient, and two is slower and focuses on understanding and completion rates. University is one example where you will receive a more detailed understanding, but with a lot more time invested. On-the-job training is usually very quick and efficient, but maybe you're not fully understanding what you're doing. So what we've taken is, we've taken all of these aspects and combined them together to find a great middle ground for training. Our program is fast-paced. You will walk out of the program knowing a lot about data science and analytics and real-world business applications, with a deeper understanding as you get from university. All of our instructors are PhD and master's holders and have completed the program themselves and know how to provide that in-depth training that you are looking for. So here are our program offerings. We are so excited to announce that for our summer 2021 cohort, we are offering 3 data-focused programs. We'll be offering our successful full-time data science fellowship program and a more flexible version of that, our part-time data science fellowship program, and now our brand new part-time data analytics program. Since this workshop is focused more on data analytics, I will be reviewing that program in more detail. However, I feel free to reach out to us if you would like to learn more about our data science focused programs. So like I mentioned, even though we will mainly focus on our data analytics program, let's discuss some similarities in all of our program offerings. All of our programs are intense. They are built around hands-on data-focused curriculums. Though we offer both full-time and part-time programs, both are packed with a lot of information and tools. Our programs are thorough. Each week we'll focus on a different data science tool or approach. In addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment, and so in each of our programs, we'll work on many projects that focus on the data tools that you are studying. Additionally, all of our programs are very collaborative. We want students not only to work with their colleagues and instructors, but also have the opportunity to network and connect with our hiring partners. And all of our programs are career focused. We have career coaches that help you succeed in your data focused careers. You'll not only learn how to present your best self by attending our career search workshops, but you'll also have an opportunity to work with the #1 resume writing company to get a polished resume and letter. And lastly, all of our programs are interactive. Each student in all of our programs are provided a Jupyter server for the duration of the course, so students can follow along in lecture and see and edit raw code that's being run. Students will also receive immediate feedback via our interactive grader. So like I mentioned, here's some more info about our data science programs. I won't go into too much detail here. If you have questions specific about these programs, we're happy to connect with you via email, or you can schedule a call. If you email us, we'll send you a link to schedule calls with us, and we can go in more detail about these programs and their curriculum. But here's just a quick overview. I'll pause for a second, and then I'll go over our part-time data science, and then we will go into data analytics. A little more about our part-time fellowship program. And again, please email us if you would like to discuss these in more detail. We are happy to do so. And here's our part-time curriculum. So we are very excited to announce our new part-time program. The part-time data analytics program lasts for 20 weeks with classes held Monday and Wednesday from 7 p.m. Eastern to 9:30 p.m. Eastern. You can also expect to spend 10 hours per week working outside of class, and office hours are available each week. The program is great for those that are still working or wrapping up their degree, as it will allow you to work full-time while advancing your data-focused career. You will receive the same excellent curriculum and training, but at a slower pace, and these sessions are live and instructor-led, so you're still able to interact with your instructor and ask questions. The application process for this program is composed of basic information, resume review, and a career goal focused group interview. There also is an optional scholarship application, which I will go over in a little bit more detail in just a minute. Throughout the course, you will work on mini projects to demonstrate your understanding of core data analytics topics covered by our expert instructors. As mentioned, not only will you be set up with a virtual environment, but our curriculum will have you working with open source tools and popular programs like Python, Pandas, Jupyter, and Tableau. We are also so excited to announce our Data Analytics Diversity Scholarship Program, which aims to help remove barriers, provide opportunities for women, veterans, LGBTQ+, and students from racial and ethnic backgrounds that are traditionally represented in technical roles. And here is our part-time data analytics curriculum broken down week by week. Again, please email us for more detailed curriculum overview. And so this is just a little bit about our program. I will now pass off to Michael to lead you through our live data analytics demo, and then I will come back on at the end to help answer any questions.
All right, thank you, Sierra. And I was going to turn on my video, but it looks like I don't have the, oh, wait, actually, no, now I do that. I'm the co-host. Although I guess really mostly what matters is that I will be sharing my screen. So I'm also going to put these links in the chat here for a GitHub repository and a binder notebook. They'll be going through some of the work that we'll be doing for today. So you can follow along with the code that I'll be writing in the binder notebook. Although I think I'm going to do a little bit of this kind of more live or interactively to sort of like show what the process of doing this kind of work looks like. So a little bit about the sort of prompt for this demo is we are going to be looking at basically taking an Excel kind of task or a task using Excel spreadsheets and work with these files using Python and some additional packages such that we can actually work towards creating something that will automate generating a report, for a bunch of similar files, which would set the stage for some stuff we'll be doing in a future demo where we take a lot of that code and use it to start building an interactive dashboard. So I have my screen share set up on this Excel file. I suppose this is very zoomed out right now. So kind of demonstrate what's in here. Well, that's very zoomed out now. So what we have here is kind of a fictional kind of fake data set that I put together covering the results of a few months of kind of like influencer marketing based like social media campaigns. We have two sheets. This one called posts has a whole bunch of rows where we have, on some date, some influencer, makes a post. We know the number of followers to that influencer. We know how much it costs for them to make a post. And we see like the likes, comments, and shares and whether they clicked the link in that post. We also have a pivot table where our columns now are a whole bunch of individual days. Our rows are influencers, and the values in here are the number of conversions, so people who not only clicked the link, but would go on to, let's say, make a purchase or whatever we've called a conversion like on the site that is linked. And our goal is to take this data and we want to compute a few additional metrics. I want to look at the cost per acquisition, for instance. So when we, this money we're pouring into these influencer posts, how much does it cost to actually get someone here, making, actually converting, making a purchase or whatever it might be. I also want to look at just the conversion rate. So people who click, who show up on the site, what proportion of them actually make a purchase. And we want to base that on, people who convert or who show up on the site from certain influencers, maybe certain groups, how many followers they have. Kind of some flexibility there to compute these two metrics. And this is something that we certainly could do in Excel, but we're going to be using the tools that we'll cover like in the Data Incubator programs to do so. Again, I have shared a link in the chat for a GitHub repository with the code, as well as a binder notebook where you can kind of follow along interactively online. But I want to show kind of live what this would look like. So I'm going to basically start by opening up a terminal. I've already got this set up so that I'm basically in the, well, I guess I'll move right here. Gonna put this somewhere, no, not here. Moving into somewhere where I have like those data files. I know it's probably funny to watch me typing around on the terminal, but please just bear with me just to demonstrate that. Let's see. In this folder, I've got some stuff, but notably, I also have these Excel files. And what I just want to demonstrate, the tools we'll be using. So I'm somewhere where I can, access the files that I need. And I'm going to open a Jupyter notebook. You can definitely do this with like a graphical interface, but because I work on a lot of like remote machines, I use the command line a lot. It's definitely a skill that we will be building in the program as well, because it's very, very useful, whether you're a data scientist or analyst. So this loads up my Jupyter Notebook server running locally on my own machine. I'm going to create a new notebook here so that I can start working with these files. Again, if you follow the binder link that I posted, we'll basically be working through that process. I just think it maybe would be instructive to see what it looks like kind of doing this live. So first thing I'm going to need to do is import some software. We're going to be using pandas here. Pandas is kind of like the main kind of canonical software library you use in Python for working with data in tables. So we kind of have this pipeline that goes from Excel to pandas. It's kind of a big focus of our curriculum and kind of just something you see in industry a lot. And we want to load in our data. Now to do this, I'm going to read an Excel file. So I have pandas.readExcel, and I'm going to put in a file path for one of my Excel sheets, right? I also want to note, I guess, looking at this notebook, I realize now that some of us maybe have not seen this before. So what is this Jupyter notebook? This is something that we'll be using a lot in the program. We use this for mini projects as well as kind of our curriculum, kind of textbook lecture notebooks. And it's used all over the place in industry and academia, kind of wherever people are doing Python and certainly data science and data analytics. Basically, it's kind of an interactive file format and kind of way of serving those files that lets us write and run little chunks of code, and also, like have kind of nicely formatted markdown text and images and a bunch of good stuff like that. So that's what I'm working in here. When navigating this, and again, this is also what you're going to see on Binder, if you followed that link. And if you are on Binder, by the way, you want to go to something called the Generate Report Notebook. You'll see something that looks a lot like this. So we have these little cells of code. I can run these either by clicking this Run button or just holding Shift and pressing Enter, which is what I will typically do. I can make a new cell by clicking Cell, maybe, or Insert, I guess, Insert cell above or below, or just pressing A for above or B for below, which is also what I'm going to do. So that's our notebook. That's where we're going to be working. And I want to load in this data, so I say pandas.read Excel. Here's my file path. I need to tell Python which engine I'm using, or we're using this thing called OpenPyXL, another Python library, which is able to deal with the XLSX file type from newer versions of Microsoft Excel. And I want to say what sheet I'm opening up. I'm just saying sheet name equals 0, so I open up the first sheet. I also could have said conversions, which is the name of that sheet. And I'm going to say index column equals 0, because if we look at this sheet, we have this whole thing of, these are basically going to be our index. Actually, no, I don't want that for the influencers one, or the conversions one. So if I do this, that reads in that file we just looked at into this big table, which is great. I'm going to call this conversions. And I can do the same thing with posts. pd.read Excel. Going to be the same path. Engine equals open py Excel, because it's an XLSX file. The sheet name, I'm calling it 1 because it's the second sheet. And the index column is 0. We see in this sheet that there's this column that's saying like just index values. We don't really care about that. We want to get rid of it. So this will be my posts. Now I can look at these posts and everything looks good. It's that table that we were working with. I also will note when we write these little cells, so if I just put the name of the data frame and I hit Shift Enter, we can see our little table. Our data frame is kind of the name of the pandas word for it here. If I want to see a couple of rows, I can say posts.head. I can use this data frame method, parentheses to run that function or method, gives me 5 rows, or I could put like a 2 in here, for instance, and get 2 rows. Let's do that with these 2 things just so we can kind of see them. Now, I need to ultimately compute some metrics that use these conversion numbers and these click numbers and these cost numbers. So I need to get everything matched up. I want to merge into one data frame. And so what we're going to do from there is we're going to try to figure out basically how to get these things into one thing so that we can compute those metrics we wanted. While I could kind of try to go through the rest of the notebook I've already written, like live, it probably would be most valuable for us to work through the sort of official copy that I already have written out rather than sort of rewriting it, because I think it'll probably be a little bit easier to follow that way. But I wanted to show just what sort of like the getting started part of this looks like, some of the motivation and like what the software looks like. But I'm actually switching over now. Again, in the chat, I pasted a link to a GitHub repository and a Binder link. So if you click that Binder link, it will take you to something that basically opens up, I guess not immediately this page, but rather you will ultimately land somewhere like here. So here's a notebook I've already written. Once again, generate report, which will do everything we need to do to compute those metrics based on our Excel file data and actually export a new Excel file that has the sort of additional information in the report. So, and that's kind of all stuff I've written up here. Again, our data has those 2 sheets, conversions and posts. So each influencer has, some number of conversions on each day. That's what's here, and their posts. So they posted on January 5th. This influencer has 1,029 followers, which puts them in group 1, people with between 1,000 and 2,000 followers. When they post, it costs us $80. We got 336 likes, 14 comments, 17 shares, 52 clicks, where someone continued from the post to our website. Again, we're loading that in like this using Python and pandas. And I'm also going to modify one of these columns. So I say posts and then square brackets and date, which is going to access this date column. And I'm going to change it to turn it into not just sort of a string like those characters typed out, but actually something that is like a date time kind of object. It's a different data type. And it's a data type that will allow us to do a lot of cool stuff. If I look at posts again, it still just kind of looks the same as it used to. But what I can do now, if I were to look at, so posts date gives me that column. Because it's this date time object, I can do things like, what was the month? Or what was the day of week? Which is 0 through 6, where this is Sunday 0, or Monday 0, and Sunday 6, 0 through 6. Is that right? Yes. So we'll be using that more later. But we're just going to modify that now. Again, we're reading in conversions and looking just at the first 2 rows of that. Again, it's this pivot table. Now, I'm interested in computing, once again, the conversion rate and the cost per acquisition. So I want the number of conversions divided by cost and the number of conversions divided by clicks. Conversions are in here, in that pivot table. Cost and clicks are in here. So to get that stuff to line up, we want to find a way to merge these tables together. So it'd be really nice if we could get something that looks like this. And for every date and influencer, also had a column that said conversions. That information coming from here, right? And to make that happen, we'll have to modify this table a little bit. Because we want to make it look kind of like this, so that we can just squish them next to each other, matching up the appropriate, person and day. That's kind of what we're going to describe down here. To do that, again, we need to change the conversions table. Instead of a row for each person, a column for each day, what I really want to see is actually 3 columns: influencer, date, and conversions, because that looks a lot like our posts table, right? And so what we can do is I can say conversions here, and I want to say conversions. I want to melt this. So I'm going to say melt my ID variables. These are going to basically become, this is something that's going to be a column that stays as its own column. We'll see what that means in a second. So influencer is an ID variable, because we already have it right here. And actually from here, if I just were to run this, versions is not defined because I did not run this cell. So if I say conversions.melt and I say ID variables is influencer, I'm going to have now these 3 columns: influencer, variable, and value, where variable is all the other columns and value is the cell for that influencer and that column. But I'd like to rename these. So I'm actually going to say conversions.melt, ID variables influencer. Let's rename variable as date. Let's rename value as conversions. And so we're going to end up with something like this. So I'm saying, all right, I have this new thing called melted. You guys said melted equals all that good stuff. And melted looks like this. And this looks like it's going to be pretty well set up to merge onto, to kind of squish sideways onto our other data frame, our posts. And that's just what we'll do. So I'm going to say my posts, merge that onto melted. On the left with posts by date and influencer, on the right with date and influencer. And I'm going to get exactly what I hoped. All of the stuff from posts plus this conversions column. I also have a copy now of the influencer column because this had a lowercase I and this had an uppercase I. So there's now a copy there, but that's OK. Now, if I look at conversions, cost, and clicks, I can get those metrics I wanted. But also, this is something that I'd like to be able to do in the future, maybe with different files. So I want to take that and I want to wrap it all up into a function, basically a piece of code that I can execute with, basically by just calling a name for that chunk of code. And I can do so in a way that's going to be very reliable and repeatable. So I've defined this function here, load and pre-process, and I'm going to pass in a path to my file. And everything in here is basically the code that we've already written. And I return something that looks like this. So now I say df, my data frame, very typical name for a data frame, kind of like canonical usage in pandas, is all this stuff. I've also added another column that says January 2019, March 2019, and so forth. We'll see why later. So everything is set up. We can compute our metrics. And to do that, I'm going to write a couple more functions. So cost per acquisition was my first one, right? How much am I spending versus how many people are actually showing up and buying stuff? I'm interested in knowing this for each influencer, maybe for each month, maybe overall, and so forth. So it's going to be convenient for me to write a function because we're doing this over and over again. So I'm going to say, basically, if there's at least one conversion, this should be cost, total cost, so cost, and then add all that up, divided by the number of conversions, summing all those up on my df that I pass in. So I could say now, use my function name, cost per acquisition, df. You always need to make sure you run your code. What am I doing here? You also need to make sure you spell things correctly, folks. So this is across all of my data, all my people, all my different days and months. On average, I have to spend $90 to get someone to show up and buy something. Cost per acquisition. Very common metric in influencer marketing and kind of content marketing in general. Advertising as well, I guess, similar. So we spend $93.62 approximately to get someone to buy something. But I can also break this down by influencer, by month, or by whatever it might be. And so I might take my data frame and group it. So I'm going to say group by influencer. And to each group corresponding to one influencer, all the rows for example, Christopher Washington, fake name, I want to apply that function. So group by, what I'm grouping by, apply, and what I'm applying, where that's this function up here. And so when I did that, this is what we got. So for Albert Taylor, we're doing pretty well, spending about $29 to get someone to buy something. For Lori Young, not as well, nearly $1,200, which means that this is someone we're putting a bunch of money into, and it's not actually leading to people buying stuff or converting, whatever we've defined that to mean. So it's very helpful for us to break this down per person. And we could really easily group by something else, such as month. These are out of order because I turned them into just like these strings. We could certainly sort them in the correct order if we wanted to. So we see kind of like how this metric has changed over time. And I could absolutely put in a little, list of things to group by, such as the influencer and then the month. And I could see, how well Albert Taylor did in each of those months, and so forth. So again, this is more pandas stuff that shows up heavily in the fellowship and I guess the analyst program. So taking our table, grouping it by values in a couple different columns, applying this function to each group, getting something like this. And to see this as a table, I can now say, reset index, maybe view it a little bit more easily. I'll do the same thing with conversion rate. So defining another function, and basically this is just going to take the number of conversions divided by the number of clicks. Because basically, I want to know when someone shows up on the website, do they actually convert, buy something, right? So if 100 people show up and 5 people buy something, my conversion rate is 5%. And that's what this function does for us. So we could do all the same stuff. I could say df, group by influencer, apply conversion rate. Did not run this cell yet. And now I have my conversion rate. I could also maybe go by something like the follower group. What I called that. Group 1, people who have a smaller number of followers than 2,000 to 10,000, 10,000 to 50,000, for instance. So I could say, oh, it looks like actually I have a high conversion rate among my kind of, micro influencers, maybe nano influencers who don't have as big of a following. We also look maybe by follower group and say apply cost per acquisition. Cost per acquisition, oops. I could say, oh, it looks like people in this group were spending a lot and we're not getting a lot out of it. People who are in the biggest group with the most followers, actually we have the lowest cost per acquisition. But then those people with very few followers, also a really low cost per acquisition compared to this one. A lot of different ways we can group it, and it's really convenient to do so because we wrote those little functions for ourselves. So this is, loading in everything and computing our metrics, from our Excel file, merging tables together. But I don't want to just keep this in a vacuum. I don't want to just keep it in this notebook. I would like actually to write it back into an Excel sheet because, we're likely collaborating with people who use Excel a lot. So this is something that they can easily open up. Not everybody already has, Jupyter notebooks on their computer or wants to use Binder. This is a familiar format, Excel. So why don't we make a little report that does a whole bunch of different groupings and computes these nice things. So what we're going to do is we're going to write this function, generate report. I'm not going to go through all of this line by line, but effectively, let's just take a look. Effectively, what this does is it lets us pass in our data and stuff to group by, and it outputs a table that looks like this. So based on our groups, we have how many posts, what was the total cost for all those posts, total number of clicks for all those posts, total number of conversions, and then our new metrics, the conversion rate and cost per acquisition for that group. Our output is going to look like this. But we want to export something that has maybe one of these per person. But we also might want to see a table, let's say by month. Maybe we want to see a breakdown by month and person. And our function that we wrote up here makes it very easy to do so. Because here I'm just saying, let's go by influencer. But I could also say maybe like by month. And get the same thing. Or perhaps just by month. Kind of get the same thing there. And so now that we have this, we can use this function and write one last piece of code here. Oh, actually, maybe one thing I'd also like to notice, things that we can do that might be useful with this report. So if I have, for instance, sorted by my influencers, or grouped, so I have all these metrics for each person, I might say like, okay, well, give me my top 5 in terms of highest cost per acquisition. Those are people who were spending a bunch of money on and not getting much out. Well, at least relatively, right? So I can say, take this. I want to sort by the values in some column, the CPA column, cost per acquisition, that we computed above. I want to put those in descending order. So I'm saying ascending order equals false. And I'm saying, give me the head of that data frame. So it's the first 5 rows. And so we can kind of see that these are in descending order. And these are the top 5 people who have a really high cost per acquisition. So if we're interested in keeping cost per acquisition low, then these are people who we might want to, stop working with, or maybe work, allocate less of our funds towards. And it also, could help point us to things like, oh, these are people who maybe it looks like they get a lot of interaction, but it's actually not useful for us. Or these are people who, maybe they have a lot of followers, but no one really engages, kind of things like that. Of course, a little example of why this might be useful and some of the decisions it can lead to. Lastly, what we're going to do is write all this stuff back to Excel. I've written another function here, write report to Excel. It's going to take in our data, and it's a file name that we're going to be exporting. By default, file name equals report.xlsx. So that's kind of the default name. So there's a few things I do here. First, I'm going to create a couple different tables, one of them by influencer, one of them by month, one of them by influencer and month. Oops. But they're all going to look like this. So influencer by month, like we saw before, and by both of them, like we also saw before. So I make those 3 report tables, and I'm going to make an Excel sheet that has all of them in there. So by influencer, that table exists now, and I can say .to Excel, right into this writer thing, which I'll mention in a second. And that's going to show up in a sheet called influencer. So what is this writer? Well, it's this thing that Pandas gives us that's going to basically create kind of like an open working Excel file with a particular name. We have to say the engine is OpenPyXL because it's an XLS file, XLSX file. And this will basically stay open so that we can write a bunch of different tables into that file from Pandas and Python into Excel as different sheets. And finally, we'll say writer.save, and that will save the file at this name and path. So when I run this, if I go back out here, I would see that I also have report.xlsx. Now, we can't open Excel files directly from here. We need Excel or similar to do that. But I can take this, click here, and I could say download. And that'll download from your binder link to your own computer. And look in my downloads. I can open up report. And sure enough, we have, and something that we don't address today, but is in the fellowship, is things like styling and formatting this sheet using Pandas. But we have that table that we made by influencer, by month, by influencer and month, where Pandas was even nice enough to do things like merge these cells for this influencer. So it's all of those months for that influencer and so forth. There is a lot more that we could do. This is a brief demo. I probably shouldn't take up too much more of this time, but we've seen a lot of the kind of big skills that we'll be kind of starting out the analyst program with. A lot of it really is working with Pandas, kind of trying to take, computing these kinds of metrics, but also writing flexible code that we can use to do things like automate creating reports. And what do I mean by automate? Well, if we look back in here, we had influencer report 1, not a very well-named file on my end, but this was the data set we started with. This was February, January, March. But I also have this one, number 2. And if we look at, say, df2, let's say I want to load and pre-process influencer report 2. Well, now I've got like April, and this is going to be the next few months. So I reused that function here. I could also say write report to Excel just right off the bat with df2. Oh, I probably should actually change the name of that file. So my new file name, we'll call it report2 because I'm very creative. I've got report2 in here. So all those functions I wrote, I reused that code really quickly and easily. Opening up a new file. And so now we've got actually April, July, June, and May. These are sorted alphabetically because I kind of made the funny choice of just using text instead of like date times for that. But the big idea is that we were able to really quickly reuse this code. This is the wrong window. Really quickly and easily reuse this code for more of these kind of, quarterly looking, I guess, kind of reports that we were working on. There's a lot more we can do, and there's a lot more related information covered in the program. It would be great, of course, to not just do tables, but maybe some visualization. It would be great, for instance, to take something like, I guess this data frame is probably good. Maybe to take something like, I don't know, maybe let's group by all of our influencers. Let's just add everything up in there. So now I've got, for instance, the total cost and total number of conversions. Maybe I just plot that. So on the x-axis, cost, on the y-axis, conversions. What do we see? Something kind of like this. So cost gets higher, and we have the number of conversions. And it looks like we have a couple of people who we're spending a whole bunch of money on and not getting anything out of it. Really easy to see that immediately from conversions, right? It would be certainly nice if I could hover over this dot and figure out who it was. Interactive visualizations like that, definitely a big thing, actually, when we have time for real lectures in the analyst program. And the last thing I'll leave you with is that it would be really nice if we could take all this functionality and maybe turn it into a little, let's say, app or program or a little website where I could just drag in that Excel file and get my interactive plots or download my new Excel report. Or even better, maybe a completely interactive dashboard that pulls up-to-date information directly from a database and gives me a bunch of visualizations. So all of these ideas we explore in a lot more detail, and definitely in a lot more over much longer periods of time, not jam-packed into a 30-minute demo in the program. But I guess you have to stick around and find out kind of how that stuff works. So things like, how do I make this code more reusable? How do I make it more interactive? How do I put it in a drag and drop kind of web app? Those are kind of the next things that we would be moving towards from here. So I know this was a lot of information very quickly. I was only kind of able to describe the code as I was writing it. Please rest assured that this moves like 10 times faster than the actual lectures and material in the program, because this is kind of to show off some of the cool stuff you'll be able to do, not to get you ready to actually do that stuff. But that's going to wrap up my demo. Thanks, everybody. I hope you found it interesting and instructive. And I'm going to pass things back to Sierra.
Thanks, Michael. I will share my screen again. Okay, so picking up where we left off, again, if you have any questions, we'll save some time at the end to answer them. So please put them in the Q&A section. But picking up where we left off, a little bit about our employment rates for our program. A big component of our program that we really pride ourselves in is helping our students not only grasp data science concepts and data analytics concepts, but also getting placed in that field. Obviously, our analyst program is brand new, so we don't have data here yet, but for our data science fellowship program, 97% of the students that go through our program are currently employed outside of academia, and 82% are employed within 6 months of completing the program. So those are really great numbers. We're very proud and have worked really hard for them. And that's part of the challenge, not only learning the content, but being able to transition into a data science or data analyst role. And that's really where our program stands out, because we help you to do both. So where are our graduates now? Where are they working? What are they doing? Again, data is not available for our analyst program just yet, but for our data science fellowship, this is just to give you an idea. Our graduates are working in 55 different industries. Some of the most common industries we see are computer software, internet, IT, financial services, and biotech. And some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and many more. These titles and roles vary depending on the company and industry, but these are just some of the roles we've placed in the past. Here is a short list of our hiring partners. Many of these companies are also hiring for data analyst roles as well, but we are also focused on building a separate network for our hiring partners dedicated solely to our data analyst program. If you'd like some more information about our hiring partners, please email us admissions@thedataincubator.com. A few of you have asked about financial assistance and if we offer any, and the answer is yes, we do. Especially during times like these, it's hard because people may have extra time to participate in our program, but limited cash flow. So we want to help you with that. We've partnered with LEAP to provide an income sharing agreement. It's great. You can participate in the program with just a deposit down and won't be required to make any payment until you've graduated and are working and earning more than $40,000 annually. We also provide loans through Skills Fund. And in addition to that, for many of our part-time programs, many companies are willing to sponsor or pay for their employees to go through our program. It's a win-win. You get to learn great stuff in the evening and being able to apply them to your job during the day. If this is something that you think your company would be interested in or you would like to present to them, we do have a letter we can provide you with that will help lay out the program and all of the benefits of attending. Let's see why this is not progressing. Okay, so where are we right now? Well, we run multiple cohorts a year, and we are actually starting our spring cohort early April, but our application for our summer cohort is now open. Our summer cohorts will run from June 28th to August 20th for our full-time program, and June 28th through November 12th for our part-time programs. As I mentioned earlier, the full-time cohort is 8 weeks long, and the part-time cohort is 20 weeks long. Some specifics about our data science application. We ask that you submit your application by April 16th for early admissions. You'll then have 72 hours to complete the challenge from the time you open it, and the challenge deadline is April 19th. You can't complete the challenge unless you submit the application. Just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues. We are unable to reopen the application or challenge after that deadline. That's for our early admissions. We also have regular admissions after our early admissions cycle. What's the difference there? Well, we really evaluate applicants on a first come, first served basis. So if you want a better chance of getting a fellow spot in our full-time program, or just knowing earlier if you've been accepted into the program to secure financing, I absolutely recommend applying for early admissions. We also offer a priority enrollment package for our data science program that includes access to a Python training course, early access to career services, and a one-on-one with a data science resume writer, as well as $2,000 off your tuition for a direct payment. Some more info about our data analytics application and timeline. Our data analyst application is broken down into 2 parts before we make a decision: the application plus the optional diversity scholarship, if you're interested, and then the interview. The application deadline for a data analyst is May 7th, and then decisions will be made on May 28th. If you're interested in applying to any of our programs, which I hope you are, you can go to the dataincubator.com/apply to submit your application. And if you have questions about your specific situation, this presentation, or going through our application process, please reach out to us at admissions@thedataincubator.com, and we'd be more than happy to answer your questions. So at this point, I will open up the Q&A. If you have questions you'd like answered, please put them in there and we will review them. So the first question is for you, Michael. It says, can you explain again what MELT does?
Yeah, absolutely. And I will pull up the notebook again to do this, if that's right. Okay. Oops, wait.
Should I stop sharing my screen? Okay.
I just took over actually. So yeah, looking back at the notebook we've been working through, we used MELT on this conversions table. Conversions started out as a pivot table, right? When we loaded it in, we had all of our influencers. We'll look at a couple more rows of this. It was in this pivot table kind of funny format. We have a bunch of influencers and we have a bunch of days. And we have, for instance, that on January 2nd, 2019, there was one conversion that corresponds to Brandon Gonzalez. We wanted to match this onto this table to create a new column for conversions, but to do that, we have to change the structure here. Rather than rows and columns like this, I would actually like something that looks more like this: a date, an influencer, and a new column for conversions. So that's where we use MELT. So going from here to here, if I were to just call MELT with no other arguments, I would get variable and value. So this is now my column names, and this is values from those. But it makes a lot more sense to keep some of those columns the way they are. So now I've got a column for my influencer. Now I've got variable and value. So this is the other column names, and then these are the values that were in those cells, right? This stayed the same. These all got squished or melted down into one column, which means that all this stuff had to get kind of squished and melted down into another column so it all lines up still. And then I just said, all right, well, let's also rename, instead of variable, say date, instead of value, say conversions. And that's what MELT did for us. It sort of unpivoted our data.
The next question is for you as well, Michael. It says, does Pandas have an inbuilt function to transport and visualize data into Tableau? Just curious how connected the two different platforms are.
You know, that's a great question. And I think luckily, I was looking into this yesterday or the day before, because I was curious as well. Tableau by default works very well with like static files like Excel, CSV, as well as kind of standard databases, SQL databases, and similar. But I actually found recently a really cool, I think still kind of in its initial phases, software library for connecting SQL to, or I'm sorry, connecting pandas to Tableau. I don't know much about it. It's, I think, a little bit convoluted the way it works. Probably makes more sense to export this as a CSV and load it in, but somebody's working on it.
Another question for you, Michael. It says, will the data science program include things like deep learning, NLP, complex network analysis, reinforcement learning, etc.? I noticed these in some of the capstone project videos. Are they part of the curriculum or specific to the individual's projects?
Sure. So deep learning, yes. Natural language processing, yes. Each of those kind of have like their well, deep learning is its own week. Natural language processing gets most of the module, along with some other advanced machine learning topics. One of our mini projects works with network analysis, kind of like, yeah, doing a lot of graph-based statistics. Depending on how complex you mean by complex, I don't know if I can necessarily say. Reinforcement learning, we don't do as, we don't really directly work on reinforcement learning. The reason for that is that reinforcement learning kind of has a more narrow kind of range of applications that we observe in industry as compared to like the supervised and unsupervised stuff. It's definitely cool and important topics, but we're short on time, so we kind of stick with the like really high demand stuff.
Another question in here is, what does the coding challenges look like for each program? I will say for the data analyst program, there is not a coding challenge for the application, but Michael, maybe you can talk a little bit about what the data science coding challenge looks like.
Sure. The coding challenge consists of two parts. I don't know if we currently call this a computer science challenge or probability challenge or something. It's a couple different names over the past 2 years. But basically one part is like questions that are like kind of classical computer science kind of and probability and like algorithms kind of stuff. The other, so that kind of tests like algorithmic thinking and kind of like basic coding practices. The other one is a data challenge. We give you a medium-sized data set. It's typically like an open data set anyone can download. That's like, you know, a public data set we're choosing to work with. Typically, it's like, I think 100 to a couple hundred megabytes, a little bit too big to be easy to use in Excel. And we ask you to compute basically a lot of descriptive statistics and do a little bit of like linear regression and hypothesis testing using that. So a lot of that, we write it in pandas, and people often use pandas, or they might do it in R. I've seen people do it in SQL. I think some people do it in Excel, which is kind of tough when it's that big of a file. But that's kind of the data challenge. You are evaluated on getting the answers right. And we also individually look at everyone's code to evaluate code quality. So do you have well-named variables? Do you have like efficient code? You know, are you following good style conventions? Is it easy to read? Things like that.
The last question I see in here is, do you apply to demo your work to hiring partners? So for our data science program, you do have the opportunity to pitch your capstone project directly to our hiring partner network. So you will have what we call pitch practice. You'll pitch it to your cohort and the instructors, and then it'll all be scored, and the top presenters will be picked to present directly to our hiring partners. You will still have the opportunity to network with them and ask questions in those capstone showcases that we host, but there will only be a selected number of presenters. So with that, any other questions? I'm not seeing anything else in the Q&A, so if we missed it, please put it in now. Okay, so I do see one that just went in there. It says, so it's accurate to say that the first part tests on algorithm and data structures, and the second part is testing on your ability to use pandas and do data manipulation and extract insights from data.
For the most part, yes. Sometimes the first part of it is, you know, it's not so much like, can you implement like breadth first search? So it's not so much stuff like that. It's usually like a little bit weirder. And often there's a lot of like probability or combinatorics involved. Depending on, I think, who writes it for a given fellowship, or kind of like what we end up going with. But so it doesn't test so much like your knowledge of classical algorithms, so much as like kind of problem solving and algorithmic thinking, if that makes sense. There's a related question in the chat I'm going to touch on really quickly. How does knowledge of all that stuff play a role in the full-time or part-time program? We have a daily coding challenge in the full-time program. I guess, you know, not daily, but I guess like a sessionly coding challenge in the part-time program as well. that is usually based on like more of the like CS and algorithms kind of stuff. We do this for two reasons. One, it's pretty common to run into questions like this in data science interviews. And two, we, basically it just sharpens critical and algorithmic thinking and problem solving skills, which is always useful, which is also why we test you on it in the data or the challenge questions.
So with that, we are right at time. So I apologize if we didn't get to your question today. If you still have questions, please email us at admissions@thedataincubator.com. We are putting that email address in the chat link for you. And then we'll also put a link to complete your application in there as well. Again, please email us with any questions and we will be happy to answer them for you. Thank you so much for attending today, and we hope to speak to all of you soon. Bye, everyone. Have a great day.
Bye, everybody. Thanks for coming.